Hello everyone, my name is Arkayuanda Febrianto and my name is 25060800038. In this video, I will explain recursion problems from exercise 2.1 until 2.5. I will show the code in Python and C# and explain each line of the code, including what each line does and why is it used in the program. Next, I will explain the code line by line and also describe the purpose of each line so we can understand how the program works. This is the Python. This is the code. This line defines a function named Fibonacci. Its purpose is to calculate the Fibonacci number based on input n. This line is the base case. It is used to stop recursion when the problem becomes simple. This returns the value of n directly when n is 0 or 1. This line breaks the problem into two smaller parts and adds their results. This runs the function and prints the results. The output of this program is 5 because the Fibonacci sequence up to 5 results in the value 5. This is the C#. This is the code. This line is allow the program to use Boolean functions like output. This defines the main structure of the program. This line defines a function to calculate Fibonacci values. This line stops recursion at the simple case. This is return the base value. This line calls the function again to solve smaller parts. This line is the entry point of the program. This line runs the function and prints the results. Exercise 2.2, recursive on list. Now this is the Python. The explanation. This line is to use to count how many elements are inside a list. This checks whether the list is empty. Return 0 because there are no elements left. This counts one element and continues counting the rest. This function calculates the total sum of elements in the list. This checks if the list is empty. Return 0 is the base value. Adds the first element with the results of the rest. Then this to display the results. On to the C#. This is the code. This line is function that counts element by removing one item each time. This stops when list is empty. This one removes the first element, so recursion moves forward. This adds count one by one. This function calculates the total sum. This takes the first value. Remove is to process next. Add values recursively. 2.3 Palindrome syndrome. This is the Python. This line defines a function named palindrome _check. The purpose of this function is to check whether a string is a palindrome or not. This line checks if the length of the string is less than or equal to 1. This is used as the base case because a string with 0 or 1 character is always a palindrome. If the condition is true, the function returns true, meaning the string is a palindrome. This line compares the first character and the last character of the string. If they are different, the string cannot be a palindrome. If the first and the last character are not the same, the function stops and returns false. This line removes the first and last character, then calls the same function again. The purpose is to continue checking the remaining middle part of the string. This line tests the function using the word katak and print the results. This line tests the function using the word Python and print the results. This is the C#. This line imports the system library so the program can use basic feature like output. This defines the main class where the program runs. This to open the class block. This defines a method that returns a Boolean value. The method is used to check whether a string is a palindrome. This opens the method block. This checks if the string length is 0 or 1, which is the base case. This returns true because a short string is always a palindrome. This compares the first and last character of the string. If they are different, the string is not a palindrome. This calls the function again using the middle part of the string. This continues the checking process. Close the method. Entry point of the program. Now this open main method. This function tests with katak and print results. And this tests the function with Python and print results. This to close the main method, and this to close the class. 2.4 Geometric Series. Now this is the Python. This line defines a function named geometric_recursive. The purpose of this function is to calculate the total sum of a geometric series, specifically the series 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus blah 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 plus 2 to the power of n. The input n represents the highest power in the series. This line checks whenever the value of n has reached 0. This is very important because it acts as the base case, which stops the recursion. Without this condition, the function would keep calling itself forever. This is when n equals 0, the function returns 1. This is because 2 to the power of 0 equals 1. This value becomes the starting point that will be added step by step as the recursion goes back up. This is the main logic of the program. Here's what happened in detail. This calculates the current value in the series. For example, 2 to the power of 5 equals 232. Now this calls the same function with a smaller value. So instead of solving everything at once, the function will calculate one value, then ask itself to calculate the rest. This process continues until it reached at the base case. This line starts the program by calling the function with n equals 5. Then it prints the final results after all the recursive calls are completed. The output is 63 because the program calculates the sum of the geometric series from 2 to the power of 0 up to 2 to the power of 5, which results in 1 plus 2 plus 4 plus 8 plus 16 plus 32. And this is for the C#. This line imports the system library. The purpose of this line is to allow the program to use built-in feature, especially console.writeLine for displaying output. This line defines a class name program. In C#, every application must be inside a class, so this acts as the main container of the program. This symbol opens the class book, meaning all code inside belongs to the program class. Then this line defines a method named geometric recursive. Static means the method can be called without creating an object. ENT means the method will return an integer value. ENTN is the input, representing the highest power in the geometric series. The purpose of this method is to calculate the sum of the series, 2 to the power of 0 plus 2 to the power of 1, blah 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 up to 2 to the power of n. This opens the method block. This line checks whether the value of n is equal to 0. This is the base case, which is very important in recursion because it stops the function from calling itself forever. If n equals 0, the method returns 1. This represents the value of 2 to the power of 0. This value becomes the foundation for building the final results when recursion goes back up. This is the main recursive logic of the program. Then this is what happens step by step. This calculates 2 raised to the power of n. This converts the results from double to integer. This calls the same method with a smaller value. So instead of solving the full problem directly, the program will calculate one value, then delegates the rest to another recursive calls. This continues until it reaches the base case. This closes the method block, and this is the main method, which is the starting point of the program execution. This opens the main method block. Now this line calls the method with n equals to 5, which will make the program execute all recursive calls, calculate the final results, then print into the screen. This is close the main method, and this is to close the class. The output is 63 because the program calculates the sum of the geometric series from 2 to the power of 0 up to 2 to the power of 5 using recursion. 2.5 Binary search. This is the Python. Okay, I will explain line by line. This line defines a function called binary_search. The purpose of this function is to search for a target value inside a sorted array. R is the list of numbers. Target is the value we want to find. Low is the starting index, and high is the ending index. This line checks whether the search range is still valid. If low is greater than high, it means there is no more data to search. If the condition is true, the function returns -1. This means the target value is not found in the array. This line calculates the middle index of the current search range. The purpose is to divide the problem into two smaller parts. This checks whether the middle value is equal to the target. If the value is found, the function returns the index of the value. This checks if the target value is smaller than the middle value. If the target is smaller, the function continues searching in the left half of the array. This means the target is greater than the middle value. This line is the function that continues searching in the right half of the array. And this line defines a sorted array. Binary search only works correctly if the data is sorted. This search for the value 7 in the array. And this search for the value 6 in the array. The output is 3 for the first search, which means the value 7 is found at index 3. The second output is -1, which means the value 6 is not found in the array. Okay, now on to the C#. This is the code. Okay, this line imports the system library. Its purpose is to allow the program to use built-in feature such as control rod line to display output. This defines a class named program. In C#, every program must be inside a class, so this acts as the main container. The symbol is to open the class block. And this line is defined a method called binary search. The purpose of this method is to search for a value efficiently inside a sorted array. The parameters are this one is the array of numbers. This is the value we want to find. This is the starting index, and this is the ending index. The symbols is open the method block. This line checks whether the search range is still valid. If low is greater than high, it means there are no elements left to search. If the condition is true, the function stops and returns -1. This value indicates that the target is not found in the array. This line calculates the middle index of the current search range. The purpose is to divide the array into two parts. This to check whether the value at the middle index is equal to the target. If the value is found, the function immediately returns the index. This check whether the target is smaller than the middle value. This line is if the target is smaller, the function searches the left half of the array. It calls itself again with a smaller range. This means the target is greater than the middle value. This is the function that searches the right half of the array. The symbol is to close the binary search method. This is the entry point of the program. Execution will start here. This is to open the main method. This line creates a sorted array. Binary search requires sorted data to work correctly. This line searches for the value 7 in the array, and it will print the result of the search. This line searches for the value 6 in the array. It also prints the results. This is to close the main method, and this is to close the class. The first output is 3, which means the value 7 is found at index 3. The second output is -1, which means the value 6 is not found in the